Hello everyone, so in this video, let us talk about another new concept in the Go concurrency playlist we have been following through. So if you haven't checked out the other videos, I highly recommend you to first check out those videos because all of these are in series and every one covers a lot of different concepts which are very helpful for you to understand concurrency. Now, in this video, we'll talk about what is mutex. But before going out to what exactly is mutex, what it solves, why it is all important, and the code part and so on, let us first understand what's the use case it's tried to solve actually. Why mutex comes into picture actually. Let us go over a code. I have taken this code, but just remove the mutex part. And this is the actual code that we want to first understand, and then we'll talk about why it is all important. So what you can see here is that what we have here is that we have a shared resource here. Now, what is actually a shared resource? A shared resource is that if we are spawning multiple Go routines, as you can see in a for loop, we have multiple Go routines has been spawned, and there is a variable, a common variable which every Go routine is trying to access. Okay, if multiple Go routines are trying to access a common variable that is called as a shared resource is being accessed by multiple Go routines. Okay, so as you can see, there are multiple Go routines that is spawned up, and what is this function doing? This function is just taking the shared resource value and incrementing it by one. So pretty much simple code. Okay, this so let's say five coroutines has been spawned up 1, 2, 3, 4, 5, 6. So okay, six coroutines has been spawned up, and every coroutine is taking this value and incrementing its value by one. So if the initial value is zero, in the end, I suppose you are thinking that value should be six. Okay, so that's the whole idea that we just want to increment the value by six, but like either in going in an incrementing like counterwise manner, every new coroutine is spawned and everyone is just trying to increment the value all at once. Now, the problem which occurs in this is, let's first check, like as you can see, first check out the code actually and see what's the actual output for this. Let's just run it. And what you can see here is the output is 5. 5 coroutines has been spawned up and 5 is the answer. Like everyone is trying to increment the value of the shared resource by 1. The answer is 5. Pretty much simple. So I suppose you are thinking that the code is right. Let's now increment the value by 50. Let's say now 50 Go routines has been spawned at the same time using this, and they all try to access and increment the value. Now the answer turns out to be 50 at cell. So as you can see now it is also running fine. Like 50 Go routines, a lot of Go routines has been spawned up trying to access the value and try to increment it. Let's say now we increment the value a little bit more, 500. From 50 I'll go to 500. Like 500 is a very large number in compared to 5. Now let's see the output. The answer is 479. So the answer comes out to be a different number. So it should be 500. 500 Go routines has been spawned up, a lot of Go routines is spawned up, but they try to access the shared resource and they try to increment it by one. So every Go routine increment the value by one. So answer should be 500. But it is 479. It is not coming out right. So now it is coming out 478. Like it is different. Okay, it comes out giving different results. Actually, also you can see. 470 like different results. So as you can see, that is an undeterministic result. Why? Because all of them are trying to access the same resource, and as the number of routines increases, what is actually happening is that what this line do, every routine will go to this variable, check, let's say the value is 6. It checks the value is 6, it takes the value, increment it by 1, make it 7 and store it here. Now it will make it 7. But let's say two Go routines come at the same time. Okay, one Go routine come at this and other Go routine comes at just the same time because they are running concurrently, and both of them see the value as 6. Now this will also make it equal to 7. This will also make it 7, and they both try to write the value as 7. Okay, that is the race condition that is happening, but the value should be, it is initially 6. One Gotin should make it 7, other Gotin should make it 8. So answer should be 8, but the answer turns out to be 7. And that is what is happening here. As the number of Gotins increases, the chances of both, like any two Go routines, accessing the same variable at the same time and checking the same value increases, and thus in that scenario, both of them will read the same value and increment it to the same value. But that is wrong because every Go routine should increment by one, not both of them should increment it to the same value, and that is causing the error. So as the number of Go routines increases, that is causing the problem. And that's the world of Go concurrency. That concurrency can lead to different results as the number of Go routines can increase. So you have to check out all those conditions. So what's the actual thing? How you can solve it out? Like what's the actual use case? So we understood like that is the what is causing problem. If you have a shared resource and multiple go routines is trying to access it, then it can lead to a race condition, and in the race condition, unpredictable result can come. So what's the actual solution for this? So now solution comes down to what we know as mutex. Now what mutex do is that whenever a Go routine access a piece of code or any variable, we'll talk about that. What it do is it take a lock on it. It take a lock on it. By lock it means that if any other Go routines comes, they are not able to access this locked or shared resource. Okay, so you can also assume that there is some room or there's some house. Okay, multiple people are standing and trying to flock to eat food. It has some food. Okay, like everyone is trying to eat the food out of it from this house. But what the actual idea is that everyone go inside, then it can cause some problem. So what it happens is it has to be have a door. Any one person which go inside locks the door, so that only one person can eat some amount of it. When they get full, it has like they come out, then they open the door, they come out, the other go, like the other person can go lock the gate again, eat the food, they get it full, they come out. Okay, that is how at every moment of time only one person can go in, have their food, like get their you can say hungriness completed, and then like they come out. That is how what is this mutex all about. Mutex is just a lock on a shared resource. Okay, so I hope you understand the actual definition, why it is important, what mutex is all about. Let us now go over the definitions, and then we'll talk about how we can write the implementation of it. So what you can see here is that if you go over the code, the definition, in concurrent programs, multiple routines may access the shared resource simultaneously. In that scenario, without proper synchronization, this can lead to a race condition and unpredictable behavior. Sync mutex provided by sync package is a synchronization primitive in Go that provides mutual exclusion. Mutual exclusion means that mutually excluded, like they both cannot access at the same time. Only one of them can access at the same, like only one time. To protect the shared data, it only happens when we have a shared data and we are writing on it. If you are reading from a shared data, let's say we have a shared data and everyone is reading from it, that is no worries to do and put a lock on it. We only have a problem when we are reading in a shared data. It ensures that only one Go routine can access and shared resource at a particular moment of time. Mutex.sync has two main methods. So this mutex has two main methods. We'll go over the code as well. One is lock and other is unlock. Lock means that when our critical section begin, the critical section, the shared resources, where should it begin? Where should we put a lock? We have to put a lock there. Whenever we want to put that, it should be mutually exclusive. And whenever our part is done, you have to unlock it. Okay, when a routine acquires a lock with this actual lock, you can say method, it gains exclusive access to that critical section. The unlock method releases the lock and allowing the other routines to acquire it. Okay, that is a pretty much simple thing. Now with the same code only, we'll talk about how we can make use of the sync mutex. So we'll just take this mutex and put it here. So we'll make a mutex like this. We've created a mutex. Now this is a shared resource. So what we'll do is that we will put a lock here. As soon as we get inside this function call, whenever we like spawn multiple routines and any routines go inside it first, it take a lock on it. So mutex, the same mutex dot lock. It will put a lock. So whenever put a lock, all the things after it is now inside a critical section that it should be accessed by one routine, mutually exclusive, only one time. So like one at a time, sorry. So one at a time, only one routine can access this. Now the mutex lock is there. Any one routine will access it, increment the resource by one, and then we have to release the lock. Because if we don't release it, then it will be all like no other routine will access this particular section. So we have to release as well. So you can release it after that, after the work is done, or whenever the function is done, you can also use a keyword that is defer. Defer is also used to be called when everything is done in the function call. So you can call defer mutex unlock. Okay, that is all what you can do, that in the function call when everything is done we have to unlock the mutex, and that's it. That's the whole idea that we have to use, nothing much complicated. We just like taking a shared resource, putting a lock. In the end, when everything is done, we are just unlocking it, and that's the shared resource that is inside this, and that is provided by the sync mutex. That's the overall idea that we have to use. Now let us run this code again with 500 again coroutines, and the answer is 500 now. Okay, so because every coroutine you're not trying to access is take a lock on it and then increment it and then release it. So whatever number of times I'll do it, it is now giving 500. Though it will increase the runtime of this particular program because now everyone cannot access it at the same time. So concurrency is, as you can see, not actually happening here. It is like incrementingly only one by one, everyone will take the place and eat it. So it is like taking some slow time because not everyone is now allowed to gain access on the shared resource at the same time. As you can see also, it will take some more time, but it provides you with additional functionality that now the discrepancy will not be there on a critical section. That's the overall idea here. Though these type of mutex is used less in real world scenarios because we generally don't use shared resources, but in some banking sectors when we are like there's a particular section everyone is adding money taking out money, so we have to also ensure that whenever we have to take out money or remove money, there should be a lock. When we're adding, no other should add at the same time. Then it can happen the same thing. There's a shared resource that there's a shared balance of your account. Okay, now if two people are adding the money at the same time, then they can cause a problem because one is adding 500, other one is also adding 500, and if the go routine that has been spawned, both of them at the same time sees the resource as 500, the initial balance is 500, both of them increase by 500 and it will become 500, but it should become 1000 actually. So that is the cause of problem when we share resources, but generally in most of the scenarios this is much less used because if we have shared resources we try not to put a lock or like we have to try to use some other method to prevent such race condition scenarios, but if we have to use mutex in this scenarios. That is the overall idea here, and using sync package you ensure that only one good in access at the one time. This prevents race condition, guarantees the integrity of shared resource. That's the overall idea and the code part for what mutex is, how it can be used. If you still have any doubts, you can mention in the comment box for this particular video. Stay tuned on this particular playlist. I will put more and more videos on concurrency so that you can get ready for interviews or any other topic which is very important in concurrency. If you have any more ideas, put down in the comment box. I will be helpful and try to make a video on it as well. I will see you in the next one. Till keep coding and bye.